I like to separate my nonpolar amino acids into alkyl and aromatic groups. So before we get into the details of each amino acid, I want to highlight the backbone that stays constant, and it's the R group that changes on each amino acid. So the best way to memorize amino acids is just to draw the R group. Glycine is the simplest amino acid with just a hydrogen, and alanine has a methyl group. For valine, I like to think that the letter V has 3 points, which reminds me that valine has 3 CH groups because it's nonpolar. So there's 1 CH and 2 methyl groups. Leucine is pretty much the same as valine, with just an extra CH group. So add a methylene group, and the same valine R group gets copied. Isoleucine is an isomer of leucine, which means that one of the groups is just moved. So the first and second groups will get rearranged. So the methyl group with methine would come on top, and the methylene group would move to the bottom, so the second position, and everything else will stay the same. Methionine is the only group in nonpolar amino acids with a sulfur. So there's going to be 2 methylene groups with a sulfur and a methyl group at the bottom. Proline's the only amino acid with a kink in its backbone, so it has a CH carboxyl group, but for amino group it has an NH, as the R group has 3 methylene groups that connect with the amino group, making it NH. Mnemonic feeling with you is for aromatic. F for phenylalanine states CH2 and a benzene group. Remember that every amino acid that's aromatic needs a compound to make it aromatic, which in most cases is a benzene group. The phenylalanine is pretty simple. Tryptophan's pretty much the same, but it has an indole, which is a heterocyclic compound. So CH2, an indole, and a benzene group that makes it aromatic. The reason I have a star next to tyrosine is because it's a polar amino acid. It's under aromatic because it also has a benzene group. So it's very simple. You just have CH2, a benzene group, but because it's polar, you're going to have a hydroxyl group at the end.